Hey guys, it's now time to tackle Caldor fact number 3. The real interest rate or return on capital has been stable. So to put things in context, the real interest rate reflects the real price of capital. So it measures how much firms are willing to pay for to rent an extra unit of capital. And of course, they are willing to pay more if they expect that its marginal productivity is higher. So how does it evolve on the balanced growth path? Well, many things are going on, but as we've seen, so first of all, the stock of capital is always increasing on the balanced growth path if there is growth of population and technology. So you could imagine that, okay, if we accumulate more, then its marginal productivity should go down. But at the same time, it accumulates more in tandem with the fact that there is more and more worker and they are more and more productive. So having more productive workers means that the marginal value or the marginal productivity of capital should be higher. So we see that there are these two things to take into account, and it makes sense on the surface to imagine that the marginal return to capital should be relatively stable. Also, something that is very important in this context of the Solow model is that savings rate S is said to be exogenous. Well, that would be very hard to sell if the say R always went up, because imagine that interest rates go up to 30-40% in real terms, then people would just rush to the bank and put their money and invest it to get better returns. So the fact that they don't do that reflects the fact that it makes sense that in the long run there shouldn't be any big difference in terms of the interest rate. So let's formalize this a bit more. Since interest rate is a price, so let's go ahead and introduce some more market structure and see what happens. So we're going to assume a representative firm with the profits represented here, capital pi of K and productive labor, L tilde, which is equal to f of k L tilde, and this is the same f as before. It has constant returns to scale, minus the cost of capital Rk, minus the cost of labor W L tilde. So normally you would see a price in front of this, but here we are dealing with real interest rates. So what has implicitly happened is that we just have divided everything by, say, P. So it would be a nominal interest rate divided by P, which equals R, and nominal wage divided by P, which equals here real wages. Another thing to worry about is, yes, but it seems strange that here you pay effective worker. Shouldn't you pay not worker and then have technology go ahead and boost their production? Yes, it's something that we can think about, but if you do the math with in another way, what you will realize is that here everything will adjust with the wage. So wage is the price, and if you include technology or not in it, then it's just going to affect what the wage measures, but it's just a way to measure it. It doesn't affect the outcome of the model. All right, so how do we find the interest rate? Well, it's like any good firm. What this representative firm does is maximize profit. And to do that, it optimizes the use of K and L with respect to interest rate. So we do that by taking the first derivative of profit with respect to K, and we get that df dk minus R has to equal 0. So df dk is the marginal product of capital, and R is the marginal cost of 1 unit of capital. So then we confirm that what I was saying earlier, that the interest rate is actually the marginal productivity of capital in real terms, since it's real interest rate. So then how does df dk evolve on the balanced growth path? So that's what we're going to find out. Something I didn't say explicitly here, but that we can find easily, is that on the balanced growth path, Y, capital Y and capital K, so output and capital stock grow at rate G plus N. We find this in exactly the same way as before. So we know that the growth rate of output per effective worker on the balanced growth path is 0. And what I just said, it's output per effective worker. So it means that its growth rate also is equal to the growth rate of output minus the growth rate of effective worker. So then I find that the growth rate of output is equal to the growth rate of effective worker, which is, as we know, equal to G plus N. Output increases faster and faster if we have better technology and if we have more people work. Same thing for capital. So I find in this exact same way that on the balanced growth path, the growth rate of capital per effective worker is 0, so that the growth rate of capital is equal in the same way to G plus N. All right, so what does that mean for us? Well, it means that if I look at the change from one period to the other of total output or total capital, I have the following. The total output in period t plus 1, yt plus 1, is equal to 1 plus g plus n multiplied by total output in period t. And total capital in period t plus 1 is equal to 1 plus g plus n multiplied by total capital in period t. And the neat trick we're going to use here is ask ourselves the following. So how much does having an extra unit of capital now affect how much capital I have one period in the future? Well, I just use this equation here, and all I need to do is take the derivative of of kt plus 1 with respect to kt, and I find that dkt plus 1 dkt is equal to 1 plus g plus n. So if I have one extra unit of capital now, I will have 1 plus g plus n extra unit of capital tomorrow. Makes sense? And now here, follow me for the rest. So same thing for output. So I have 1 plus g plus n times yt output tomorrow. It's equal to my output tomorrow. So let's just substitute yt by f of kt L tilde t, and same thing for tomorrow. So yt plus 1 is equal to f kt plus 1 L tilde t plus 1. And now we take derivative with respect to the exact same variable on both sides. So with respect to kt. So this is just some constant. So I get that df of kt L tilde t dkt on the left side equals to df kt plus 1 L tilde t plus 1 dkt. All right. So nothing fancy here. And now, so note that here Lt is something that is not affected by kt, something that is just there. It's exogenous in the model. So really what I have to do is take the partial derivative of f with respect to kt. And here I have kt plus 1 and kt here. So I'm going to use the chain rule and observe that this is exactly the same as df kt plus 1 L tilde t plus 1 dkt plus 1 multiplied by dkt plus 1 dkt. And I can just use the fact that I already computed this. So it's equal to 1 plus g plus n. And what is df dkt? It's rt, as we have computed earlier. And what is df dkt plus 1? It's rt plus 1. Let's divide by this constant on both sides, and then we really confirm that actually the real interest rate does not change. So it's really because everything grows at the same rate, and it's a reflection of the fact that f has constant returns to scale. So all its input grow at the same rate, and then we really see that even from one period to the next, the marginal productivity of capital always it remains the same in real terms. So Kaldor fact number 3 holds. So it's looking good for the Solow-Swan model.